We have created K-12 websites, books, trainings, webinars, lessons, videos, activities, state soil booklets, I love soil stickers, and more. And we are happy to have you here to learn about some of the things that we're doing. To get us started, let me introduce Susan Chapman, the Director of Member Services for the Tri-Societies.
Hello, everyone. Welcome. I'm delighted to be here. So what I wanted to do was talk a little bit about the project and the grant and what the objectives of it are. If I could advance my slide, there we go. So this project was done with a cooperative agreement with NRCS. And the goal was to develop some educational resources to address a lack of awareness and understanding of the importance of soils in everyday life. And, you know, that is really some of the mission of the Soils K-12 committee as well. So the focus of this agreement, we really wanted to do some outreach to urban and underrepresented groups. We wanted, even though we have a lot of materials, we wanted to be able to develop a turnkey online resource for members to take into classrooms. So we said we wanted to conduct 2 in-service workshops in urban locations, then do an assessment of those trainings to make sure that the materials that we had put together were relevant and appropriate for teachers to take and then take into their classrooms for their students. And then what we're doing right now is disseminating those resources to both educators and to all of you. So we developed a web page as well. It's called soilsforteachers.org/inservice. And to save time, we're not going to go to it right now, but I wanted to give you a sense of what is on this web page, and we'll go back to it later. We have, for every module, and you'll be hearing about them, there's a PowerPoint, there's a video presentation that we recorded in Chicago at the in-service in Chicago. There's information about all of the different activities that we did. And we even have a video trailer that talks about the project for teachers to get a quick glimpse of what we did. And one of the things we wanted to do for the teachers was to give them the materials to take right back to their classrooms to use immediately. And, you know, we know that a lot of teachers may have limited funds for resources. So we created, as part of this plan, a soil science bucket. Big 5-gallon bucket, big I Heart Soil sticker, lots of materials, all of the things you need to do with all of the activities. We also gave them a copy of No Soil, No Life, Soil Get the Inside Scoop, and we even compiled in a big booklet all of the resources that are on that webpage. And the teachers used that throughout the entire in-service to take notes. So with that, I'm going to turn it over to Briana Wyatt.
Hi, thanks, Susan. My name is Briana Wyatt, and I'm going to be discussing both the soil basics and soil chemistry. So our first module is soil basics, and this is where we started our in-service each morning. So we begin by introducing just some of the basic soil physical characteristics, the primary one being soil texture. So we described how soil is composed of different mineralogical sizes, sand, silt, and clay. And you can see just some of the visuals that we included in our presentations and the importance of soil texture for determining things like the soil's water holding capacity and permeability. And then the next thing we discussed was how you can use the percentage of sand, silt, and clay in a soil sample to estimate the soil textural class using a textural triangle like the one shown here. So to show the teachers how they could do this for their own sample, we had them take the soil probe that came in their soil bucket that you just saw a picture of, and we took them outside and showed them how to use that soil probe to collect a sample, which they then took inside. So you can see here, the teachers really enjoyed getting outside and having a lot of fun with that, collecting their own soil samples. And then we went inside to do the first activity, which is the NRCS texture by feel method. So many of you are probably familiar with this. It's very simple. All you need is a little bit of soil, some water, and then the flow chart to determine which textural class your soil sample falls into. So the teachers really enjoyed doing this, and most of the time they thought their students would enjoy it as well, because what kid doesn't like getting their hands dirty? So that was our first texture our first activity in the soil basics module. Our second activity, our second module was on soil chemistry. And this module had 2 activities that we did. So the first activity is called Soil as a Filter. And in this activity, we demonstrated to the teachers how soil itself can be used to filter out both physical and chemical pollutants, because soil particles themselves have a charge associated with them. And depending on where you're located in the world, we assumed, these teachers are going to be based in the US. So most of these soils are going to be negatively charged. And so this gave us an opportunity to talk about things like the cation exchange capacity and some other similar concepts. And then the activity was filtering Kool-Aid through the soil samples that they had just taken from outside. So the figure in the bottom right gives just an example of what you might expect the outcome of that activity to look like, where a sand would not remove any of the colored dye from Kool-Aid, but the actual soil sample, the true soil sample, is capable, because it has that negative charge, of removing some of the dye. So the effluent that comes out of each of these filters looks different depending on whether or not the Kool-Aid was run through sand or a natural soil. The second activity is a determination of soil pH using just a normal pH test strip that you could buy from any store. So again, the materials are fairly basic. You just need some pH test strips, some distilled water, and then some soil and something to hold the soil. So it says you can use a specimen jar with a lid, or if you want to just use a cup and stir it with a stirring rod or a spoon, you could also do that. But all you have to do is add water to your soil, stir it up, and then wait for the soil to settle a little bit, and then use the pH strip in the supernatant of the solution that sort of sits at the top of the sample, and wait about a minute or 2, and then you can estimate the pH of your soil. And a lot of the teachers weren't sure why that might be important, but on the next slide, there is a table that indicates suitable pH ranges for different plants, including flowers. So many of you may be familiar with hydrangeas and how they vary in color between blue, purple, and pink. And this is because of the pH of the soil that they're grown in. So a lot of the teachers had like school gardens, and they were interested in growing certain things. So this simple pH metric might help them grow plants that are suitable for the soil in their location.
Hi, everyone. I'm Jennifer DeBruyn. I'm a professor of environmental microbiology at the University of Tennessee. And so for Module 3, the focus was on soil biology, or the living component of soil. Go ahead, Susan. Yeah, so the first idea that we cover in this module is about soil as a habitat. Basically, that soil is a complex and 3-dimensional habitat whose properties change with space and time. And we explore that using a group brainstorm. So the first prompt that we give them is really getting the teachers, the participants, to think about what soil is like as a habitat. Susan, if you can advance. Yeah, what do you think the soil habitat is like? And really guiding the teachers, students, to think about soil as being a place that's dark, it's moist, there's tunnels and pore spaces, air pockets, water films, there's mineral stuff, and there's lots of dead and decomposing organic matter, and just kind of thinking like a soil microbe. What is your habitat going to look like? And then the second prompt we give them is to start to connect organismal adaptations to that habitat. So then we ask them, what adaptations would organisms need to survive in that habitat? So go ahead, Susan. And so you're guiding them to think about what types of organisms would be successful in soil, and really leading towards the fact that these organisms would be small. They would have to use chemical sensing as opposed to sight cues. They're going to grow fast, reproduce fast, and adapt to a wide range of conditions. And that we find lots of organisms there that can use that dead and decomposing organic matter as a food source, i.e. decomposers. The second big idea that we talk about is that there's abundant and diverse forms of life that exist in the soil habitat. Because of all the range and the variability in the soil habitat, we get this huge diversity of microbial life that has adapted to live there. So we start by going through some examples. I show them some pictures and flashcards of different types of organisms that we might find in soil. And then we explore that using an activity called a Berlese funnel. This is an old and kind of classic way of separating soil organisms from the sample. So if you can advance, Susan. Yeah, there we go. So essentially a Berlese funnel is a funnel with a support. You can put a leaf litter or a soil sample on with a heat and light source above it. Soil organisms hate to be warm and dry. They want to be cool and moist. So they're going to migrate down through that funnel and into the preservative fluid at the bottom. So we show them how we can make that at home using really simple ingredients. In this case, a cut-off milk jug, a lamp, and a small glass to separate that. And we talk about how you can look at the organisms in the bottom and kind of explore the diversity of life there. The third big idea that we cover in this module is that it's really about the function of these organisms. What are they doing down there? And so this idea is that soil organisms are performing essential ecosystem functions such as decomposition of organic compounds, carbon and nutrient cycling, and soil structuring. We talk generally about some of the bigger functions than they do, and then we dive into two specific functions. The first is about soil structuring. So we use the soil glue demonstration. This is a simplified version of a wet aggregate stability or SLAKE test. And we use that to illustrate how the compounds that soil organisms make are really what hold and cement soil together and give it that structure. The aggregates and the pore spaces in between that are really so critical to a healthy soil habitat. And then the next function that we look at is decomposition, which of course is a hugely important piece of what soil organisms do for us. And for that, we introduce them to the Soil Your Undies demonstration. Really a fun variation on the cotton strip decomposition test. Here we're burying 100% cotton underwear in the soil for various periods of time and looking at the decomposition of the underwear as a way to talk about soil organisms and their decomposition. So really altogether, the take-home message from this module, Susan, if you advance one more, is that life above ground depends on life below ground, i.e. no soil, no life.
Hi, everybody. My name is Missy Holzer, and I'm on the K-12 Soil Science Committee, and I'm here to share with you a little bit about Module 4. Next slide, please. Within Module 4, the whole premise behind it is that we want teachers to think about the role of soils in what we call the critical zone, and somehow with the processes within the critical zone that take place, that we can reduce the atmospheric carbon dioxide. And so to do that, this little module walks them through a number of steps. First, we want to make connections. And so if you look at that little image in the upper left, you can see that there's a lot of little slips of paper. And the bottom line is that we want them to be thinking about all of the ways that carbon might be cycling through multiple spheres in the earth, as well as the earth system, and as well as soil. And what we do is we get them to start out very small, but then we get bigger and bigger and bigger when they start thinking about, oh, carbon's here, carbon's there. And then we also want them to think critically about the arrows and the direction those arrows are pointed, and the processes that take place in those arrows when we go from what we call a reservoir to a sink. So it's the whole systems thinking that we get them to start with in regards to the carbon cycle. From that, we get into within the carbon cycle, we talk about the long carbon cycle and the short carbon cycle. And we think about the roles climate plays in soils in the carbon cycle. So which is basically the short carbon cycle as opposed to the long carbon cycle. And then we get into talking about, well, what is the cycling of carbon like within within soils? And there was a wonderful article in GSA Today about a year ago that talks about using the analogy of a bank to talk about the ebbs and flows, the money coming in and the money going out, or the carbon coming in and the carbon going out as related to a bank account. Which in the case of teaching and using analogies is one way to help students conceptualize something that might not be easy to conceptualize. So as we go through those particular steps, we move into, next slide, please. We move into what does this look like in the classroom? So the teachers could use that little activity with the arrows and the pieces of paper to kind of think about writ large the carbon cycle, but there's also provided what we call a 5E lesson, which is a 5-step lesson that talks about that gets students engaged with the climate system and the different components of it related to soils. So more importantly, and most importantly, is the role of water, plant, soil, water, and carbon dioxide and how they all cycle. They start off with engage, where we're looking at images of perhaps drought, and we think about why that has actually happened and what's taking place with explore within the plants and how soils are involved with that. Next, we get into a little bit of a discussion on carbon sequestration and how plants can actually help us store, as well as soil can help us store. And we get into next after that a little bit deeper in the mechanisms that cause all that to happen, and we learn how to model that. And finally, the students are introduced to a project that asks them to think about the way that carbon can be sequestered when thinking about the food items that they eat in their daily lives. So that kind of takes us to the end of this module. And then we move into module 5. Within module 5, next slide, please, we have a few things. First off, we have web tools, then we get into wrapping up our workshop with looking at evaluation and resources and wrap up and a general wrap up of the whole workshop. Let's take a look at the web tools. So the two web tools that are shared with teachers, just very briefly, is the NRCS Web Soil Survey and their walkthrough and how they can get to know and really understand the soils that are in their backyard, but also learn about the suitabilities of the soils in their backyards. That was definitely one of the ones I loved using with my students when I was in the classroom. Next slide, please. We're also introduced to Soil Web. And Soil Web, as you might be familiar with, this has the capability of actually using it in your smartphone as well as using it online. There's value to each one of these tools, and there's actually an activity that's online on the in-service page that marries both of these tools together, and creating a nice little learning sequence for students. Susan? Or I'm sorry, Briana.
Yes. So we conducted these workshops, one in Memphis and the other in Chicago, and we gave the teachers who attended a survey both before and after we conducted these workshops. And so here you can see some of the results of the pre-workshop survey on top and the post-workshop survey on the bottom. And what we found in both cases, and I'll go through them each, but in both cases, in both Memphis and in Chicago, both the teachers indicated that they had a little bit of knowledge before these workshops. That's indicated by those red bars that are the tallest one in each of the subject areas. But then after our workshop, on the graph on the lower part of the screen, we see that all of the teachers felt as though they had either, moderate or extensive knowledge, and their content knowledge in each of these subject areas was increased as a result of the training. Next slide. So was their comfort in teaching these subjects. So you can see at the top, prior to this workshop, the majority of these teachers felt very uncomfortable teaching these subjects in their classrooms. But at the bottom, we see after the workshop, the majority of teachers indicated that they were very comfortable teaching these subjects. So this is a really strong change from feeling very uncomfortable to very comfortable with these subjects. And the next two slides are the same thing for Chicago, where we see teachers felt that they didn't have much knowledge and weren't very comfortable, and the shift to having more content knowledge and feeling more comfortable with the content. And then the next slide just has some of the feedback that we got from teachers. A lot of these teachers, this was the first time they had received content-specific teaching on soil science, so they really enjoyed it. And now I think we go back to Susan.
Right, thank you. I am going to stop my share so I can do just a really brief soilsforteachers.org review for you. If you have not been to soilsforteachers.org, we have had a soilsforteachers.org website probably for about 15 years. It's gone through several iterations, and it all actually started with the getting ready for the soils exhibit at the Smithsonian back in 2007, 2008. So let me just share my screen really quick again here. Can everybody see the website? Excellent. So this is our the landing page for soilsforteachers.org, and we've got it classified in several different ways. We've got the soil basics, which goes directly to a page, and then there's a lot of links off of that page. We've got a drop down of soils by subject where you can find out more about each subject, and then there's also links to various articles within each of those sections. Around the World is probably one of our favorites because we developed something called state soil booklets, sort of expanding on actually what NRCS had, the one-pagers about each state soil. Members from the K-12 committee diligently put together like about an 8-page booklet for each state. We have Guam and we're finishing up Puerto Rico right now. So you can go to any of these states and click on it and get to the soils booklet. You can use it in your classroom, and there's an activity and a worksheet. Like Soils for Subject, we've got Soils and People, which has a lot of different informational pages as well. Then the Lessons and Activities section. There's a couple of important pages here. This Lessons and Activities search was done with a cooperative agreement with NRCS a while ago, and it helped build a database of a teacher can go in and search by grade level, by topic, the resource type. If they want to connect to the science standards, Missy, who you heard from, connected all of these activities to the science standards for us. So teachers can go in, they can sort, they can create binders, they can download the activities to do in their classrooms. We also took the No Soil, No Life book that we talked about, big No Soil, No Life book, and created an educator's guide, which was actually the basis for this in-service. Just really quickly, it goes, we don't have time to go to the link, but you can certainly explore it. We've done 3 or 4 different webinars on teaching in the classroom, or actually for teachers, and you can access the webinars there. And finally, the in-service guide that I had showed you a quick snapshot of when we got started. You can access any of these activities. You can access the overviews, the PowerPoints, the videos. You can help teachers with them. You can use them, and then please take them into the classroom to help the teachers. So anyway, that is our in-service webpage. So with that, we would like to, this was a really fast overview of this project that we have been working on diligently for about 2 years. So we'd like to just open it up for any questions. Comments, feedback.
There is one question in the chat. Someone asked, To get an idea about the soil texture of some land, how many samples do you have to collect from a large area in order to have an average, an idea of the average soil texture? So this is a good question. If you guys don't mind, I'll just jump in and answer it. So it depends on what your purpose is. If you're a farmer, if you're doing research or anything like that, you know, suggestion is something like 20 samples per acre. So it's a lot of samples. But if you're just doing this, for example, in a school garden, probably just 1 or 2 samples is going to be plenty for that purpose.
There's also a question from Comfort Ate, if you would like to jump in.
Yes, please. Can you hear me?
Yes.
Okay, thank you so much. Great presentation. I really appreciate this presentation, especially being a teacher educator myself. And this is something that I am really passionate about, and really encouraging agronomists to come into the classroom, not only to share information on soils, but many other things that we do in the field of agronomy. I am an agronomist, my background, but now I am a teacher educator, and I want to really compliment and thank those who have been engaged in this project. But my honest and feedback on this is on getting teachers to actually appreciate how they can use tools in agriculture, agronomy, in soils, in their classrooms. I get it that the teachers came out there and it was really fun to touch the soils and get those things. I get it also that we are trying to make sure that we are aligning agronomy or agricultural soils to the national science standards. And me being part of this too, I invest with the national science standards. And I know that teachers would really appreciate to use whatever we are doing in soils or agriculture in general, but they're still challenged in actually saying how they can fit all these activities into what they have to teach in the classrooms. They are faced with the national standards, with the assessment, which is what is really important to them. And so for me, I see the soils, all the hands-on activities like the phenomena, one thing that they can actually use in enhancing their students' knowledge on the standards that they are supposed to teach. And so for me, I really want to see where we can bring the teachers, the science teachers, with the agronomists together and actually learn from the science teachers their standards and how they would want to see these things actually help them in enhancing the teaching of the things that they're actually supposed to teach the students, the things that the students are actually being assessed on in their classrooms. Again, thank you. I appreciate the presentations.
And I can make one quick comment. So like this project is just one of the things that the K-12 committee is working on. The website you saw is another one. Annually, we go to the National Science Teachers Association conference. We have 2 booths there, a big 10 by 20 booth, and we bring different activities with us. We bring different materials. We talk about how they can use things in their classroom. Missy is instrumental in getting us to have a workshop every year at the National Science Teachers Association conference where teachers attend, and we go through a lot of the different activities that we talked about here, and again, talk about how they can integrate into their classrooms. It is an ongoing process and continuous communications.
Thank you, Susan. I know that. We are doing it and we just need to continue to do it. For me, I see a lot of potential for teachers using everything that we are doing in soil science. And I just pray and I wish that the leadership can really take it and listen to the agronomists who are doing this work and make that groundbreaking thing in the classrooms, because it's not only a way to teach science, it's a way to build the young generation of agronomists, the young generation of soil scientists. Thank you again. I really enjoyed the presentations.
Thank you. And it looks like Brandon has his hand raised.
Yeah, this is Brandon Hall from West Central Illinois. I'm an agronomist here in Central Illinois. I just wanted to say kudos to putting this stuff together. You know, as a former soil judge, someone who has a passion for soil judging and sharing the importance of soil science in my community, in many outreach opportunities, a lot of times as I go to share those experiences, my knowledge is in the collegiate level, and so it's nice to have some guidelines or some outlines to bring it to the level of these students K through 12. So I give you guys kudos to give me some tools to bring it down to the level that they can then relate to. You know, not always do we have teachers that are willing to understand this knowledge, but as we use these professionals that have a passion for soil science and bring those in as outreach opportunities, I really enjoy the resources that you guys have put together. So thank you very much.
You're welcome. There was a question about, were the connections to science standards made by state? Maybe I'll throw that one to Missy.
Not by state. We chose to do it at the national level for the NGSS.
And if I may add, the NGSS is national. More than 45 states have adopted it, and even states that have not adopted it, they have adapted it. So it was a good thing that they aligned it to the NGSS, because that is kind of the national science, that is in the science that is nationally recognized, and all the science teachers or schools, that is what they are actually aligning their teaching to.
Yeah. So we have adaptive and adoptive states, and I think there's 2 holdouts that are completely different. Actually, Florida, Texas, and I think one of the Carolinas might be North Carolina are completely different from the NGSS, but others have adapted or adopted.
Briana, here's a question. For the soil chemistry demo, does it matter what Kool-Aid brand you use?
That's a good question. You know, I only used the brand name, and I have been told that that's the right way to go. I don't have any experience with off brands. I have been told that this will work if you just use food coloring alone instead of the actual Kool-Aid itself, but I think for best results, it's best to spend the extra, I don't know, 10 cents to get the name brand Kool-Aid packet.
And someone asked about presentations. Yes, so remember, all of the presentations are on the in-service page. All of the videos that each of our presenters did in Chicago was videotaped, and it is on that site. So you're welcome to actually share those with teachers, look at them, take the PowerPoints, adapt as may be needed. If you're going into the classroom, we want people to freely use these resources. And credit the Soil Science Society of America, of course. Okay, any other questions? All right. Well, thank you all for joining us. We were really excited to bring you the program and everything that we did. Everybody poured their hearts into this. And so we wanted to share it with all of you. Please share it with anyone else, any other soil scientists that may be going into the classroom and need something that they can take and quickly use. All right. Thank you, everyone. Bye-bye.